All right, couple things I'm looking at. Question one is a price. It looks like I see years and I see price. Okay, usually my Y will be some sort of cost, amount, or price. Usually your change in X or your X is going to be some sort of time. So in this case, I'm looking at a price in 1980 of 110. So I can make even a chart here of 80 years or 1980 and have it be 110. And I can look at 88 and say, okay, I have a price of 126. Now, here's your time. Here's your amount. Change in Y over change in X. Now, I specifically made this to be 16,000 over 8 so that you had a nice smooth number to work with, such as, now, this means every 8 years, the change in price is going to be 16,000. So that means it's about $2,000 for every 1 year, right? Now, when I say linear model, I'm talking, just like I put in parentheses here, y is equal to mx plus b, okay? Now, y being my average price per home, so I could say price per home will be $2,000 for every year, and as far as a constant, that's always, okay, what is the price at 0 years? 0 years is really 1980, so the price at 0 years is 110,000. Now, if you're trying to solve for 2008 price, that's 2,000 times the 58 years plus the 110,000 for the price. So all you're really doing is taking the 2,000, multiplying it by the 58 years, adding the 110,000 that you originally had, and you get a price of 2018 of 226,000. Again, that's, if it goes up $2,000 for 58 years plus my original price, I'll have 226,000. Now, another question I asked, well, what will the price of the house be when the price is 174,000? So price is P. So 174,000 equals 2,000 per year plus the 110. So basically what I'm doing is solving for the amount of years. So I could subtract 110,000. So I get 174 minus 110. It's about 64,000. So basically the change in price is going to be about 64,000. Now if I divide by 64,000 divided by 2,000, I get 32 years. Now what year is that added to the 1980? Well, I could just do, it's 20 to 2012. It would have been 2012 here. And that's your year. Because I'm adding the 32, 1980 plus the 32, and I end up with the 2012. That's a very good question here. Let's take a look at the salary for an athlete. Now again, you're looking at a chart here where you have years, which tends to be your X, and salary, which tends to be your Y. And I could see right away, even without a slope, I have a plus 10 in years, and I have a, well, let's find the difference here. 207 minus the 175 So basically the change in y is 32.5, you could say. And then that's for every 10 years, so that means it's 3,250 per year. Right? And that's just doing the change in y and change of x. Now, whatever your change is, that's your slope. So when I make a linear model, I say, okay, y is equal to 32.5 times x plus the original salary. So what is the salary? What is the salary at year 0? This is technically year 0. This is year 10. So on a graph, year 0 is technically 1960. Right? Year 0 is technically 1960. And technically at 1960, you're at 175 here. So that's your y-intercept. That's why you identify that as your y-intercept. And here's your linear model. Your y equals mx plus b. And if I want 2018 salary, it's same as this question here, 32.5. I have 59 years here. Plus the 175. $32.5 times 59 plus 175 gives me 366,750. Just looking at this, I believe here in this question there's actually a mistake because I put 58 years for my amount of years thinking about this question, where really, if I'm asking for the price in 2018, that wasn't 58 years, that was 38 years. So really we should have done 2,000 times 38 plus the 110, and should have done 2,000 times the 38 plus the 110. I forgot a 0 there. 3, 4. We should have got 186,000. This is your correct answer. This should have been a 38 because we're looking at 1980 to 2018, which is technically 38 years. I made a mistake there on that question. Question number 3. This was, your typical school dance banquet question here. I like to make a list of things. $580 to rent, $12 per person. Okay, this is something that can change. The $12 per person is something that could change. The $580 is going to be constant. That's not going to change. So that's how I identify this as my y-intercept and this and the $12 per person as my slope. Because that's going to change. The cost, T, will change as more persons or people are added to the dance. But ultimately, even if 0 people show up, to the dance, it's still going to cost me $580 because I've rented that, let's say, auditorium, and then the price will essentially go up from there. Now I asked number of students for $1,500. So basically, I'm asking for two separate things. I'm telling you your total cost is $1,500, and I'm asking for the amount of people. So okay, we would take the $1,500, we would subtract the $580, and you would get, without renting, minus the rent, you have $960 to spend on a certain amount of people. So divide that by $12 per person, and it's 76.6. You can't have 0.6 of a person, so we'd say that's 76 total people. Again, cost for amount of people, these tend to be the easier questions because you're just plugging in how many people you have and adding the amount of rent you had towards that. So you have the 12 times the 150 plus the plus the 580. And the cost for 150 people would be $2,380 there. Last question. Bringing something to life here in California. Some forest fires, we've seen that. This is something very real, something you can identify with, something you've seen on the news. So basically we have 1,260 acres. Okay, that's something that are burning at a certain rate. 60 acres, spelled that terribly wrong, acres per hour. Okay, which means every hour, so if 1 hour goes by, it'll now be down to 1,200 acres. So what does that mean? It means that the change in Y is going to be negative, right? It's going down. 1,200 minus the 1,260. If you're looking at this as your Y2, Y1, you notice that this is actually going down by 60 per hour. So the key here is recognizing that this event, a burning event, is a negative event, meaning it's a negative slope. And we're burning 1,260 acres. So, and if I ask how many hours for a complete burn, well, how many acres will be left if there's a complete burn? There'll be 0 acres left. So I'm solving, all right, what's my amount? That's a terrible 6. What's my amount, or how long will it take to basically get rid of 1,260 acres? So I could subtract 1,260 from both sides, and I could have negative 1,260 is equal to negative 60x. I could divide that 1,260 by the 60, and I'd say, okay, negative and negative is positive. 21 hours. 21 hours the fire department has before this state park will completely